presentar brevemente a nuestro keynote speaker de hoy, que es el doctor Forrest Shull, de Carnegie Mellon University y del Software Engineering Institute. Bueno, Forrest es también presidente electo de IEEE Computer Society. Estamos muy contentos de tenerlo acá porque tiene una experiencia, una larga trayectoria en lo que es transferencia tecnológica, específicamente en el área de ingeniería de software. Así que gracias, Forrest, por estar aquí.
So I'm so excited to be here with you today. This is a wonderful event. I'm very pleased that I've been able to come down and talk to you and share some of our experiences that we've had in the U.S. I'm going to be talking today about some work that we've been doing for the U.S. government, but which has, I hope at least, more general implications, which I think it'll be fun to talk through. Okay. Is that presented? Okay.
Yeah. Thank you.
Oh, there we go. Okay. The one thing I'll say before I start is that I come from a part of the United States where we tend to talk very fast. And so I apologize, I'm speaking to you in English today. And when I get excited, I will start to talk fast. And if that happens, just wave, let me know, because I want to make sure I'm communicating as much as I can. Okay? Okay. So, like I said, what I'm going to be talking about today is some work that we're doing for the U.S. government. And what we're looking at is adopting Agile methods at scale for some of the more critical software where we haven't been able to do that in the past. Okay, so I'll talk a little bit about the challenge, why we're trying to do this first off, why we thought this was a good idea. I'll say a few words about culture change and just why that makes it so hard. And I think there'll be hopefully some larger lessons there, because I think this is a culture change issue that we all go through when we try to adopt Agile for the first time especially. And then I'll end up with some lessons learned. And I really wanted to call this lessons learned and hypotheses, because I'll be honest and I'll say we're still in the middle of our journey. Some of these lessons learned I have a lot of confidence in. Others are hypotheses, right? I think this is the way forward, and we're going to learn as we go in a very Agile fashion, of course. And at the top in blue, I call this a research and practice story, because I know that one of the themes of the event today is bringing the research and the practitioner side together. And I've always been a researcher. I consider myself a researcher still. But to do this work, I've really gone over and joined the government team and been working much more on the practitioner side of trying to adopt new practices, new policies. And so sometimes I think it's like a curse. When you think you're doing something really well, suddenly you get to flip over to the other side of the wall, and now you're the person using the results that you were doing before and that you thought were good. And you, I think, learn a lot about what makes good research or impactful research along the way. So having that context in mind, I wanted to talk through some of this. So first, I titled this talk Agile in Critical Contexts. And critical context is just a loose term. I intended it to encompass a lot of the different types of software that we tend to do at the government level that we tend to look at there. My definition, which is just one that I made up from myself, is to say that this is software that has to operate in very highly constrained contexts. That is, there's some, how do I say, there's a high demand for engineering rigor. These are systems that have to work well, and they have to work well the first time, or else there'll be some very bad repercussions. Whether that be a huge loss of investment, whether that be human life in the line, whether that be national prestige. And so what we're looking at here is really trying to put a net around things that we in different contexts would call safety critical software, security critical, mission critical, manned systems. And what I've tried to put here at the bottom of the slide is some of the examples that we've had so far in our context of trying to adapt Agile. What we're doing is not new. What's new about this particular project I'm on is doing it at scale and really changing the way that software happens in the large for the government so that we can bring in more Agile practices. But we've had a lot of good examples, kind of isolated ones, but for example, the one on the left, some of the software that we use with our NATO allies to talk about diplomacy, to talk about activities that we're doing in various countries and make sure this can all be coordinated. Okay, so you can imagine that these systems now interface with a lot of systems from each of the mission areas from our member countries. These all have to talk to each other and do the correct thing. So this is somewhat of an engineering challenge. We've had isolated examples of doing this with NASA, with our spacecraft, including manned at this point. Within the Defense Department, where we track threats, make sure that we're responding to things that are out there. Obviously, you want to make sure that nothing gets through. So these are systems where we have a high expectation for reliability and that they're going to work correctly. And then the one that's kind of hiding in the background there is a more interesting story in a way. It's a couple years ago, one of President Obama's signature initiatives was a new healthcare system. And the idea was that anyone across the country would have more access to healthcare and be able to come to a website where you could understand what policies are out there. So it was trying to make it more easy for people to get matched up to healthcare and insurance. And so this is a system, again, where if you look at it, it sits at the nexus of all these other private insurers, as well as kind of state marketplaces. So it's a huge thing. It works at scale. And when it rolled out, it was a disaster. It did not work. People could not get to it. And so it was, in a way, a national embarrassment. That President Obama had put forward this thing that a lot of people depend on. I mean, whether or not you have insurance can be a life or death situation. And it fell apart, because, at least initially, because of software. And then the reason it's here is that there was a team that came in and, using Agile practices, managed to bootstrap that system up and get it working in the end. So it was I think, one of our first real success stories of why waterfall, even in this government type situation, is not going to work well, and why Agile is one of the ways that we're going to be able to do these things better in the future. So why, again, we've had some of these initial experiences. Why use Agile for critical systems? The pushback has always been that these systems are so important, that they require all this upfront analysis, that I have to get it right, and that means I do the analysis in depth, even if it takes me a long time, and then I can build the system to those specs that I've come up with. And what we're finding is that even in these critical situations, that's not a good assumption, at least not all the time. I would hate to say that there's ever one approach that works well for everything, but certainly it's not the only approach for these type of government systems. What we're finding over and over again is that speed is important, even here. Speed in the sense of getting things in front of the users, so I can understand how the users intend to use these systems, and that's true whether it's in defense, whether it's a healthcare system, whether it's in NASA. Sometimes the users of my system are other engineers, but that doesn't mean that I don't need to kind of bring these things along in concert and be able to understand that in real time, by putting real prototypes in front of people. Okay. Secondly, one of our recurrent problems with these types of critical systems is that the technology underneath us changes so fast. We all work in software. We all know what a dynamic field that is, and from my point of view, it's sometimes a cause for paranoia, that if you stand still and you're not always learning, you get obsolete very quickly, yes? And that's exactly what happens to some of these systems, that if I do years and years of analysis up front to try to get it right, to make sure I understand the engineering, by the time I build the thing, it's using technology that's obsolete and no one wants to use anymore. So we have to get better at that. And then finally, I've talked on the previous slide about some of the expensive failures that we've had just by trying to use waterfall in this type of environment, even though that was kind of the standard practice up until now. Okay. And if those aren't good enough reasons, well, if you work in some of these critical systems, what happened in 2018 was that the US Congress got so fed up with some of the problems that we were having that they passed a law that said we have to adopt Agile within the US government for these critical systems. Okay. So if you think that your job is hard, and I know it is, but at least you don't have the US Congress looking over your shoulder and telling you how to do things better. So you can take that home and maybe remember that in some dark moments. But what their law said was a number of different things. One was that there has to be a study on how to streamline acquisition for software better in the government. And this is really the report I'm talking about today. It's how do we do software better to meet the needs of these critical systems in a government context. Talked about looking at the commercial sector, what can we bring in, promoting rapid adoption of technology. You get a sense of maybe of where some of the frustrations were on Congress's side, and I think they were actually quite reasonable ones. And I've tried to talk through some of this. In a way, I would say this is, even though we're trying to have a practical impact with this work, it still is something that requires research. And so this is, I think, a good example of, again, why one of these issues where the research and the practice communities comes together to do something really productive and impactful. Like I've said, these systems have a very different risk profile from most of the ones that we're used to applying Agile to, I think, at least in more commercial environments. As I said, if I get this wrong, people could die, essentially, if my system does the wrong thing. That tends to focus the mind in a very good way. And it makes you very risk averse, I should say also. Secondly, the way things work in the US, I'm sure you could imagine, is that the government tends not to do things on its own. So we don't have large communities of government engineers that build things for the government, typically. What we do is we outsource most of that to industry and use the private sector to kind of bring in the engineering responsibilities. What that means is that everything we do on the government side then is at arm's length. So I'm not directly engineering the software, but I'm acquiring software someone else has engineered. So that creates a challenge as well. The value proposition is very different. So we're used to, I think, with Agile, looking at the feedback loops it allows me to have to make sure that what we're doing is matching the needs of the users and being able to make sure that they can do their jobs well. That's important, but with some of these critical systems, that's one dimension among many. And so in particular, where it gets really, I think, somewhat difficult to apply the methods as they are typically applied today is in things like, this is just an example, but let's say the nuclear power plant software. There's a lot of software that is just, we hope will never run, actually. And so it's very difficult for that type of system to put it in front of a user and say, is this really going to do what you need it to do? Many users really haven't thought through that, don't really know what it means without some of that upfront engineering. So that's a challenge. Testing under representative conditions is a challenge. And so for many of these systems, the software is embedded in a larger hardware system, the software that runs in a nuclear power plant, for example, or software that runs on a jet fighter. You can't really test that in isolation because so much of how the software is going to activate is depending on the hardware that runs underneath it. And these tend to be, again, custom hardware systems even. So the testing and really making sure that these systems are doing what they're supposed to requires a lot of hardware in the loop testing, which can be expensive to set up and hard to do in really representative conditions all the time. So again, another level of challenge there. These are large systems. They tend to be very complex and sophisticated. And then for some of them, again, where I have them on custom hardware solutions, the hardware and the software tends to evolve simultaneously. And so not only can I not make a good assumption up front about what that hardware underneath me is going to do, but I might make an engineering decision later along the line that says, I thought I was going to do this capability in software, but I'm going to push it over to the hardware side, or vice versa. And so again, it's not only do I have tight feedback loops with the software and the software stakeholders, but I'm in a larger context, which is also changing all the time. Okay, so these are some of the challenges that we're keeping in mind as we go through. So from a researcher point of view, the first thing you want to do is to say, okay, well, we think we're addressing a problem. Does that problem really exist, or is this, do we have just some anecdotal evidence that says this is a problem? And so what I'm showing here is a sample of some of the project data that we've had from these critical government systems. There is no one large database where all these systems would have data together, and so what I'm showing is just a sample. It's not complete by any stretch of the imagination. But what I'm showing on the x-axis is the number of estimated hours. And so again, something unique I think about government systems and critical systems is that because it's taxpayer money, we do have to estimate upfront how much this thing is going to cost, and is it really worth the government investing in? So even though we're in an Agile mindset, we have to somehow estimate how much this is going to cost at the end of the day. And then on the y-axis, we have the number of actual hours. So how good did I do in terms of my predictions? And what you can see is that anything that lies along the green line means that my estimate and my actual were pretty much on top of each other. Okay, that's where we want them to be. And we see there's a lot of data points that are kind of plus or minus, but within a reasonable zone there. There are some encircled in red here where we actually had a significant reduction. We came in much cheaper than we thought, which is again somewhat reassuring to see that does happen. But we do have a lot where they're kind of in that upper left quadrant there, where they came in significantly larger than I estimated them to be. Okay, maybe not the majority, but enough of them, and the deviation is high enough that these are really, if we have a sense that waterfall that we've been traditionally using is not doing a good job, that seems to be based on something real. And then this kind of shows some of the same data, but in a slightly different way. This looks at more percent growth, and as you'd expect, for smaller projects, where the denominator is smaller anyway, the percent growth might be larger. But again, what you see is that there's a lot of clustering around the mean. So we tend not to do as bad, maybe, as we sometimes give ourselves credit for. But there's enough of the long tail, that goes up at sort of the top of the chart there, where you say some of these systems were really quite disastrously over budget, over effort. So yes, this is a real problem that we want to solve. And this is where it gets to why would you put a researcher like Forrest on the team? Well, part of this is, okay, we have a large body of evidence out there. So we're not, as a government, stepping into this and saying that we're kind of reinventing something from the ground up here. I did not do an exhaustive search, but one of my go-to people when I look at empirical studies of software engineering and Agile specifically is Lori Williams. And I saw some of her earliest papers were from around 2000. So let's say, assuming that she's, I think, one of the earliest, at least to my knowledge, that gives us about 2 decades worth of experience where researchers have been looking at this Agile phenomenon, trying to study it, trying to measure it, and publishing peer-reviewed papers about it. So we'd like to think that after 2 decades, we have something helpful that comes out of the research side. And the answer is yes. It doesn't get us all the way to where we want to go, but yes, it's a very good starting point for this. I think what the literature does really well is it gives us a good sense of what some of the challenges and the risks are going to be. There's a lot of experience cases out there in particular that you can learn a lot from as you go through and read and review what's been done before, especially if you look at what's been done in the automotive industry. I think there's a lot there that carries over. The picture of what's this going to do to me in terms of cost, quality, schedule, the things that I care about if I'm a program manager trying to manage these things, that surprisingly, I think, to me at least, is a little bit muddier. And I'll look at some of those examples in just a second. And then, of course, the frustration for us is that it's only a minority of the papers that have been published that really, I could say, is in contexts that are really like ours with these types of critical systems. And so even though there's a large body out there, the number that I want to draw from, at least specifically, is quite smaller. Okay? So it's good. It kind of what's there in the research, I think, gives us the path forward. But there's more research to do, and that's what I'll be talking about today. This chart I just wanted to hit very quickly, just to give you a sense. And this is, I'm going to pick on my own research. So this is work that we did a couple of years ago now. The intent was to do a meta-analysis. So there's been a lot of studies out there looking at things like test-driven development, which is a very critical practice for us as we look at these critical systems. What do we have in terms of evidence about what it does in terms of delivered quality and then team productivity? Okay, so every check in these tables is one study that we categorized. We looked at it by the type of the study. We looked at whether it's things to the left side of the chart mean that TDD did better in that context. Things on the right side means TDD did worse, at least on that dimension. And I was very proud of this as a researcher. I thought this was great. I mean, it kind of pulls together a large set of literature, tries to summarize what it means there. And then, as I said earlier, when you step over to the other side and start to use this to make really impactful decisions, what you find is it's useful to have. I mean, it tells me that there's a lot of context variables out there that are going to change the way the Agile practices really do work in the real world. But if I'm trying to take something away that says, how is this going to, can I make a prediction about how these variables are going to look as I do this adoption? It's very hard. I mean, I have data that shows up on both sides of the chart. So some studies where these things did worse, some did better. There's a lot of variation across the different types of things. And so you see different answers if I'm looking at an industrial case study versus a controlled experiment. And so, but I don't know which one is better or worse for me. If I'm trying to make this decision, do I look at the industrial case study where that really had much more of the context relevant for myself? Or do I look at the controlled experiment where I say, okay, the measurements there I think are going to have much more rigor associated with them? And so when I say that the overall picture is muddy, this is what I mean. You can look out there and you see examples on both sides. And it still takes you as a decision maker, or in my case, the person who's giving information to the decision makers, to try to pull this apart and to look at the context variables and to make some bigger decisions there myself. Okay. In terms of culture change, the way that we began this, again, based on that mandate from the US Congress, was to say what we need if we're going to do this right is to bring in outside thinking. There's such an entrenched engineering process that's been in place within the US government for so long that we really need someone from the outside to look at this and give us some honest feedback. And so what I put here are the major members of the studies team that were stood up. And what you see here, I won't go through everybody in detail, but a lot of Silicon Valley folks. That is, we really did want to look at commercial practice and understand from the folks that are doing these types of systems, especially we have a vice president from Google here. Google certainly works at scale. Google systems are certainly large scale, they're intensive, there's potential to really get things wrong and have a bad repercussion there if I do things the wrong way. One thing I'll point out interestingly is that Ms. Palka there, at the time was the executive director of Code for America. That's a volunteer organization. And so in the US, I don't think we do a particularly good job actually of things like e-government, of trying to make government data available to the citizenry. And what's kind of jumped in to fill the gap is a volunteer organization where they take coders from around the country to help develop applications that use government data and present it in a way that the actual citizens can make sense of it. So anyway, it really does require a lot of different perspectives to look at things and kind of shake people out, you know, when we're looking at a culture change of this magnitude. Okay. If you're interested, I can only give some of the highlights today. And what we did on the study team was to do the usual, a literature review, a number of case studies, data analysis, and then some pilots, to kind of look at Pathfinder programs to change the context and then see how it works. If you're interested in the full report, this is actually something that is, it's unclassified. It's available for everyone to take a look at. You can find it at the link there. And it's actually a good read. It's written in a way, I did not do the writing, I'll say that up front, except for some small parts. But the folks that did this in a way that I think it's very accessible and actually enjoyable to read, if you can believe that, for a government report. And so I'm putting now, in terms of the culture change, that study team, bringing the outside perspective up against the system that acquires these critical systems for the government is so large that what I like to do is call it an ecosystem, because it's really a number of different engineering competencies that are completely disassociated from each other. There's whole organizations that do these things, and there's communication channels, but they're very formal, they're very regulated. And so I've tried just to give you a sense up here. The things around the outside of the circle, what are the things that are changing all the time? We understand that I can't do this predictive software, because the mission is changing, my funding is changing, the policy changes all the time. So even in this context, we know we're always going to be changing. And what that hits is all these different bubbles here represent another part of the organization, that they all have to come together to work if we're really going to do this Agile adoption. Okay? So at this level of scale, for example, there's even, there's kind of the underlying engineering practice. There's a separate organization that does test and evaluation for us. So you want that independent. It's actually, in the US, it's by law mandated that you have an independent engineering quality assurance check that comes in and looks at what the engineering has done. So there's an independent test organization. There's a workforce, how we staff these things even is a whole other set of regulations and environment. And so what we're finding, at this scale at least, is that we can get the program managers, the people who are undertaking the engineering for these particular programs, to adopt Agile and to kind of recalibrate the way they do things. But if I as a program manager am doing iterative and getting things in front of the user suddenly, but before I can get it to the field, I still have to go through a year and a half of independent tests, I haven't really solved the problem at the end of the day. Okay? And so what we're finding is that every practice that we put in and try to bring things along, it's tied to a whole organization and a whole ecosystem that's still used to doing things the traditional way. And I'm whining in a way. I guess that's why this job is hard. But again, I think what I hope and believe is that by looking at things in this extreme case, in terms of Agile adoption, I hope there's a lot of lessons that we understand about what is it that's critical. What is it that, even if we do this in a more forgiving environment, what are the important things that we don't want to lose sight of? Because this really tends to focus you in on what are the things that we have to get right. Okay, and that brings me to my lessons learned. And I, again, apologize, especially since I was invited here by an empirical research team. I don't have a lot of data on the charts. We're not allowed to share a lot of the internal specifics of the programs that we looked at. But again, there's a lot of good anecdotes and a lot of good data in some ways in that report if you want to go take a larger look. So what I'm doing here is just abstracting up some of what we've learned without maybe all the evidential backing behind it. But at least I would like to talk through this with you and kind of get your feedback too if we have opportunities later today. The first thing, and what I put here is kind of one thing that we do track in these critical systems over time is what percent complete I am. So if I have a set of capabilities I'm trying to roll out, the one thing the government always wants to know is how close. Am I getting there? Am I progressing on target? Am I going to meet that delivery at the end of the day? And I'll talk through this data in a moment, but to my mind, what this shows me is that even at the high level, what it always looks like is that our programs are just not getting done on time, that we're always kind of not to the percent complete that we want ourselves to be. And when you look under the hood and look at the data, what you find is that these programs are trying to behave in an Agile way, and they're just in this waterfall straitjacket that makes everything look a little strange. And so to my mind, it's a heartening thing that says the underlying engineering is really being done in the way that we expect it to be done. It's the level on top where I'm trying to make sense of this and convey it to decision makers where I have some problems. Okay, so what we see here, if you look at the dots here for year one, things are going along, the program is making progress, and then as I get to 80% done around there, suddenly I shoot backwards, and so now my cost growth has gone up, but also my level of completeness has gone back. And if you just look at the end numbers, this seems like a very bad situation to be in. But what it actually meant was that someone recognized that this program was making so much progress, and now my needs have changed. I said, oh my gosh, you've been able to do this. Here's some more capability that I need. And so what we see is it's behaving in an agile way. The user's looking at what you've been able to deliver and suddenly understanding, oh, but what I really need is this additional set of capability. But because I'm in a kind of a waterfall environment, it makes it look like I'm running backwards. Okay. And so not much magic here. And then you kind of see this thing happening over and over again, that I'm sawtoothing up the chart, and I'm always, every time I try to get close to being complete and I have something I can put in front of the user, I suddenly fall backwards again because someone has put more stuff on my plate. Okay. So nothing magic here, and this is certainly not the way we'd like these projects to be done. But again, what I see underneath it all is something that says, regardless of how I was trying to manage it, there really is a benefit to agility. That the agile practices are trying to be put in place and doing the best that we can with it, even if I'm in an environment that's not so great. Secondly, the critical thing here, and if I only get through one of my lessons learned, it would be this one. But what we're trying to do is to make sure that as I put agility in place, I don't forget all the lessons I've learned about what it means to do quality software in this. Whatever else I can do, however beneficial any of the agility is, I cannot deliver worse quality software because, like I said, at the end of the day, something important is really riding on this. And so and this I would put more in the category of a hypothesis. I think we have a lot of good rationale behind it. I think we've seen good examples so far, but I would say they're anecdotal at this point. But what we're finding is that the way to make that happen is really not only to do agile practices and agile processes, but to have a DevSecOps, DevSecOps maybe is not the word everyone knows. We used to call it DevOps, and now what we've done is insert security in there as a first order priority, so we've come up with DevSecOps. But what this means is I have the tooling and the automation underneath me, that as I'm kind of going through this process, I'm not losing any of the rigor. I still have to be able to satisfy that independent test organization. I still have to accredit my software that it's actually safe to put in place in the systems where I'm trying to do it. But what I'm doing is not building it anymore and then handing it off to somebody else that can't do their testing within my time frame if I want to be agile and deliver things iteratively. But I'm trying to bring as much of that automation in up front as I can. So that all the testing that I want to do, not all of it is amenable to automated testing, but everything that is, I want to make sure I'm automating it and I'm bringing it in, and I'm not doing it at the end in a big independent test suite anymore, but I'm doing it every day if I possibly can. I'm sending that software every night and making sure I haven't broken something. I'm putting it through its paces and making sure that the quality is there and that I'm building to it. And again, this really requires a whole culture change in and of itself, but at the end of the day, and I would put this as a hypothesis, and if someone has opinions or data on this, I would love to hear from you if we get a chance to talk over the breaks. It really requires, it's this last bullet, that's the key one here. That is, again, when we launched into this, a lot of the pushback about why I can't do Agile is that these systems have to be secure. Not only do I have to build it right the first time, but I can't have any kind of risk of somebody getting in there and doing something strange with it. And the way that the organization has traditionally done that is to say, that means I need to freeze my baseline. When you give me software, I need to analyze the heck out of it, and then we can never change it because any change is going to potentially introduce risk. And the sea change here has been to say that, no, that's exactly the opposite way of thinking about it. That if I'm going to be adapting and if I'm going to have a secure system, I need to do this with speed because those threats and those adversaries are going to be changing all the time, and I need to be able to respond in the same type of time frame as that. And like I said, I think this is a hypothesis now. I'm not really sure how you would empirically demonstrate that that's a true statement. But it's again, the sense of everything that I thought I was doing before is 180 degrees wrong. And what I have to do now to be secure is to be speedy and to be able to check these things. And make sure that my DevSecOps is always checking me to make sure that I haven't done anything crazy or slipshod as I'm going down that path. Again, another major change here is that what we want, again, we're talking about major systems. We know that these critical systems are going to take years to build, and sometimes. That's just the way that we've been used to thinking about it. And what our study has done is to try to convince people to look again at this the other way, to start small. Don't think about building the whole thing and doing all that analysis up front, but to think about what's the smallest piece that I can actually demonstrate some value from. And so it really gets into how do I take those Agile principles and bring them into this environment? You know, if I'm looking at software that's going to run on in a cockpit of a plane, it's not immediately obvious what's the smallest piece of that that's going to add value. You know, and so this really does require, you know, the whole community coming together and thinking through how do I do this. But what we really want to make sure happens is that we can start small and then demonstrate some value. You know, get some working software out. Even if I know that I'm going to be continuing to evolve and add capability to that for years to come, at least give me some confidence that this team is able to do things. With Waterfall, we've had too many examples where we've had 5 or 6 year projects and the contractor has gotten the work to do and come back and encountered problems and things roll along and eventually it gets killed. And it's amazing to me how many times you can have a 6-year project where the contractor delivers no working software at the end of the day. I mean, talk about a horrible risk to the taxpayer dollar. So what we'd like to do is to kind of change this all so that even if you're working on these large systems, you demonstrate something that says, yes, you can do this. You know, you put something out that shows up front that you have the capability to do it. And I think that it's these Agile principles that become so important again in this context. Kind of going along with this, the idea that speed and cycle time are important. You know, even if at the end of the day what I really care about measuring is criticality, you know, that this thing is safe, that it's secure, that it has all the capability I want. I also need to measure speed because that tells to me whether or not this contractor team is able to deliver things or not and you know, get things in front of the user so that we can make sure, you know, very possible our conception of the system that you were going to build was wrong. You know, so get me something so that we can look and make sure together that things are going in the right way. And finally, and when I say that by looking at things in the large, sometimes it reminds us of things that are important in the small that we tend to lose sight of. I think that one of the things that's been underpinning this whole study is that the talent matters. That we can have, what we're doing here is trying to rewrite practice, you know, and we're trying to, you know, take what Congress has put into law and make that the policy of the US government for these things. I'll tell you that we can have the best policies at the end of the day. We can have perfect policies. And if we don't have people in place that understand the software, that understand the domain, that understand agility, we will still fail. We will not get where we want to go. And so it really puts a finer tune on, you know, just how do I know that the workforce is able to do things? You know, how do I select people? How do I know which teams I really want to be building these systems for me? And again, I think this is something that every company struggles with. I've never found one that has a good idea of how I grow talent or how I spot talent. I think I can recognize it when I see it, you know, but I don't know how it got there necessarily. You know, developers look good on paper sometimes and they turn out, you know, to actuate very differently in the real world when they get to things. So I think being able to try and understand this again is a research project that we need to work on together, government, industry, and academia. Oh, and then finally, I think this is the last one. That from a government point of view, these critical systems are systems. You know, so the fact that software is in them is nice to me. But if if what I'm trying to do is get my healthcare listed, you know, is getting a fighter plane that flies the right way, I don't necessarily care that there's software in there. I don't care how much of the capability is in software. I just want it to work. And so making sure that we have the ability to make those connections between the software and the rest of the system that's in it and do this at scale, you know, is one of the major things. And again, what we've been doing here is try to change the culture. You know, everyone that's worked on these systems is used to being able to push back and say, no, I'm not going to do agility because we are different. We don't look like the software that commercial companies done. And what we've tried to do is to say, but there's more commonalities than we give ourselves credit for. You know, we have to find the places where we can start, bring agility in, and maybe if there's other places that really do require all this upfront analysis, let's kind of defer that till next time. But by saying that it never applies, we're doing ourselves a real disservice to where we're trying to go. So that's I've tried to give you in 40 minutes or so kind of a real overview of a lot of the work that's been going on. Like I said, that report is about, well, I don't know, it's 300 pages, but like I said, it's well written. If you're interested in more, it's out there for you to take a look at. What I like to do is to end the talk by saying, in a way, sometimes I like to just step back and say the fact that we're all working in software, I think we get a lot of, I'm extrapolating wildly here, but I think it's generally true with all the software engineers I've met. We tend to get a lot of benefit out of the field that we're in. You know, it's fun and it's exciting at the end of the day to be able to create systems that work and do things for other people. The fact that some of these systems and the software, the things that we're doing rise to the level of national importance, critical importance, that's kind of nice. In some ways, I wish it was something that the U.S. Congress paid attention to because we were doing it well, not because we've had some problems. But I do believe that together our community is really embarked in something that is changing the world and is really doing something that makes a difference for the citizens, for the people that don't really care so much about software anyway. Again, by looking at by Agile practices in this particular very specific, and I would hate to think that everyone in the audience sat there and said, that's not me. I'm not building this, those kind of critical systems. I hope that there's commonalities, that we can look at that and say that by looking at it in the extreme case, there's still things that I understand better about my particular context and the things I do day to day. And like I said, I've tried to call out some of those, and these are the things that sometimes we can lose sight of. As if we're in an environment where we're just trying to get the code out day to day, going through sprints is no guarantee that I'm learning as I go, even that's what they're there for. Walking through the process doesn't always mean that I get to do that learning and understand the feedback cycle and really bring that in. But at the end of the day, that's what an Agile approach gets me. And that's why I think it's so important that we kind of keep that idea there about retrospectives, and what are we learning as a team? And what am I learning as an individual about what it takes to do software in the right way? Workforce and talent, being able to pay attention to where we have the good talent, helping to bring along, even though it's more an art than a science, I think, although I'd love to hear your perspectives on that, bringing along the talent that we do have so that people are always growing and enhancing their capabilities, that they're being able to do these systems and being able to produce good software to answer the need that's out there in terms of the lots of different capabilities. Again, being able to do these things and apply the rigorous process. Underneath it all, we're all engineers. Software engineering really has to be an engineering field. And so making sure that we're not shortchanging ourselves or taking shortcuts where that rigor needs to be there is an important thing to keep in mind. And then finally, as I said before, whatever organization, whatever circumstance I'm in, that idea of making sure that I can get to an MVP or some equivalent thereof. How do I demonstrate value? How do I really usefully engage with the customers and put something in front of them that they can give me feedback on so that we're learning together what the system needs to do? I think whether I'm working in the small or in the large on one of these critical systems, these are all, I think, the underpinnings that we have to keep in mind as we go. And then finally, I want to leave you with the thought that I've tended to gloss over, but there's a lot of different stakeholders in this work that I've talked about. I think that we're doing something good. Hopefully you had that same impression from the talk, but it requires the practitioners, the folks that are building the systems. It requires government, in this case because they're acquiring the systems, in other cases because I'm looking to government to fund some of the research work that we do together. And then it requires the researchers to be there, to take a step back and to have the opportunity to have that reflection, which isn't always easy when you're on the development team. To be able to put some data together that says, are we having some nice anecdotes and maybe they're taking us in the wrong way, or do we really have the underpinnings for understanding the field that we're going through? It really does require all of those different communities coming together to do this work in the right way. And that's why I think it's exciting that we're all here together today. That's why I think it's exciting that we all get to hear from different perspectives as we go through the symposium for the next little while. So again, thank you for having me. I think I'm out of time. I'll be around if there's conversations to be had over the breaks, and thank you again.